Welcome. In the previous video, we have learned about what is force and types of force. In this video, we are going to learn about inertia and pressure. Let's learn about inertia. We have seen that an object changes its state of motion due to force. In the absence of a force, object exhibit a tendency to remain in the existing state of motion. Let us see the following examples. Try this. Take a postcard and keep it on glass. Keep a 5 rupee coin on it. Now skillfully push the card. The coin straight away falls in the glass. Have you ever done this? Now do another activity. Hang a half a kg mass from a stand with a string 1. Tie another string 2 to the mass and keep it hanging. Now pull the string 2 with a jerk. The string 2 breaks but the mass does not fall. Heavy mass does not move. Now pull the string 2 slowly. The string 1 breaks and the mass falls down. This is because of the tension developed in the string 2 due to the mass. Types of inertia. First, inertia of the state of rest. An object in the state of rest cannot change its state of rest due to its inherent property. This property is called the inertia of the state of rest. Now second type, inertia of motion. The inherent property of an object due to which its state of motion cannot be changed is called its inertia of motion. For example, a revolving electric fan continues to revolve even after it is switched off. Another example, passenger sitting in the running bus gets a jerk in the forward direction if the bus suddenly stops. Now third type, directional inertia. The inherent property of an object due to which the object cannot change the direction of its motion is called directional inertia. For example, if a vehicle in motion along a straight line suddenly turns, the passengers sitting in it are thrown opposite to the direction of turning. Always remember, the tendency of an object to remain in its existing state is called its inertia. This is why an object in stationary state remains in the same state, and an object in motion remain in the state of motion in the absence of an external force. Now our next topic is pressure. You must have observed the tires of two-wheelers and four-wheelers getting pressurized. The air filling machine has a pressure indicating dial or a digital meter showing the digital reading of pressure. The machine fills the pressure to a certain value. You are aware that a force has to be applied for filling air in the bicycle tire with a hand pump. By applying force, air pressure is increased and then the air is pushed into the tire. Are force and pressure related? Let us see activity. Take some sharp pointed nails and push them into a wooden plank by hammering on their heads. Now take a nail and hold it with its head on the plank and hammer it down from the pointed ends. Let's see one more activity. When pressing the drawing pins into a drawing board, they get into the board easily. By applying a force using the thumb, one can push the pins into the board. On the contrary, while pressing ordinary pin with a thumb, the thumb may get hurt. What does this simple experiment tell? The nail easily penetrates into wood from its pointed end. From this, you will notice that when a force is applied on the head of the nail, it is easy to hammer it into the plank. Use your brain power. It is easy to cut vegetables, fruit with a sharp knife. A blunt knife does not work here. Why does this happen? The force exerted perpendicularly on a unit area is called pressure. Formula of the pressure is force upon area on which the force is applied. Presently, we are considering only the force acting on an area in a direction perpendicular to it. Unit of pressure. The SI unit of force is Newton and the SI unit of pressure is Newton per meter square. The SI unit of pressure is Newton per meter square or Pascal. In atmospheric science, the unit for pressure is bar. Here 1 bar is equal to 10 raised to 5 Pascal. Pressure is a scalar quantity. If area increase, pressure reduces for the same forces. And if the area decrease, the pressure increase for the same force. For example, due to natural adaptation, the bottom surface of camel's feet are broad. Hence, the camel's weight is exerted on a large area and the pressure on the sand is reduced. This is why camel's feet do not penetrate into the sand and it becomes easy to walk. Dear students, we are going to see the remaining topic in the next video. Thank you.